Okay, let's continue. Let's continue. This is now part two of the video. So let's proceed to the external entities. So the external entity represents a person, an organization, or it can be another system that provides data or receives output from the system. So it provides data to the system. The person, the organization can provide data for the system, or that means it is in that case it is a source because it provides data. And ayan, ito na yan, source supplies data to the system. And if it receives output from the system, then it is called a sink. So the symbol is actually square and usually shaded. Actually, in the diagram, it's not really shaded. It is shadowed. There's actually a shadow for gain and sarson. So an external entity, the name of the external entity is actually a singular form of a department, an outside organization, or other information system, or a person. Again, let's take a look at our original diagram. Later on, we'll be trying to read the whole diagram, explain the whole diagram, but now we're just looking at the part. So this is an example of an external entity. So it's the name for this one. It's the name of another system. So it says here, student records system. This one is the name of a person, or yes, a person, student, and this one is also another person, student. It can also be a name of a department. Let's say, for example, college, computer studies, or graduate school. So these are examples of external entities. Again, let's proceed. Yeah, these are again examples. So in this case, the customer will provide payment information, maybe the payment itself, and then the payment will be applied. So the apply payment is now the process. So how can we apply the payment? Of course, we should know the payment coming from the customer. Okay. So we can prepare bank deposit. So once we prepare the bank deposit, our output will be received by the bank. So again, in this example, the first example, the customer here is a source, while in the next sample, the bank here is actually a sink. For this one, the customer can place an order. So yung order information will be used to verify the order. Once the order is verified to be correct, then this process can issue invoice to the customer. So in this case, the customer is both a source and a sink. Okay. So here's another example. We create a paycheck. So once we create a paycheck, what will be our output? The paycheck. Then the paycheck will be given to the employee. The employee also gives the time card. Then we verify time card. So this is another example of the employee. It is actually both a sink and a source. Okay. So again, these are incorrect. One entity to another entity, and we have data flow. So the data will not move from one entity to another entity. There should be a process that will move the data from one entity to another entity. And again, the customer or the entity cannot store data to the data store directly. A process will do the storing of data. The same is true with this. We cannot read the data. There should be a process that will be used in reading the data. So basically, if we're going to look at yung mga invalid or mga incorrect, there should always be a process in between. That's why this is some sort of a summary. A process to another process, that's okay. A process to an external entity, that's okay. A process to a data store, that's okay. But if we have, let's say, data store entities without a process in between, then that becomes wrong or that's not okay to use. Let's say, for example, an entity to another entity, of course, that's a no-no. Entity to a data store, again, no. Data store to another data store, again, no. Again, there should always be a process in between. Now, how do we construct data flow diagram? So to construct data flow diagram, usually we start with the context diagram, which is the highest level. Then after we do the context diagram, we can actually uh, we can explode the diagram and we produce what we call the diagram zero. I think this was shown in our first slides. Okay, but I'll be discussing this as we go on. Now, the diagram zero can still be extracted into more detailed diagram, and that is where we can have lower level diagrams. So, up to the point where we think that everything is already clear to the reader. So, but in most cases, some will do only from context to diagram zero. Again, we only have lower level diagram if we think it is needed. So a context diagram is actually a top level view that shows the system's boundaries and scope. One process symbol, so it's only composed of one process numbered as zero. And the process is drawn in the center. Data flows connect the process to the entities. So conventions for data flow diagrams. Each context diagram must fit on one page. Process name in the context diagram should be the name of the information system. So take note of that. So the process in the context diagram, it is not actually a verb, but it should be the name of the information system. So that's only for the context diagram. So use unique names within each set of symbols. Do not cross line if possible. Use a unique reference number for each process symbol. We'll take a peep at the next one. So I'm going to erase. Let's go back. So again, context diagram. Let's take a look at our context diagram and let's now read the first diagram we had on our first slide. So this is an example of a context diagram. So the context diagram will contain only one process, and that process actually contains the name of the system. So in this case, it is not actually a verb. It is the name of the system. And then what will be shown in the context diagram is actually the name of the system, a single process, and all of the entities. So when you say entity, it can be a source of data and it can be something that or something or someone that receives data from the system. So if you're going to look at this, it, it, it means here that the grading system we have, just try to imagine that the grading system here is actually some sort of a class record, an electronic class record, just like, let's say, for example, you have a grading system done with Microsoft Excel. So if we have a grading system, first we need to have a list of students. So where are we going to get the list of students belonging to our class? Maybe we have a student record system. We have another system. So we can retrieve the names of the students and have that as an input for our grading system. So this will becomes a data source. Okay. And then of course the grading system, that's why grading system can produce final grades. And the final grades can be used to update maybe the student record system of the school. Let's say again, let's say maybe this is an Excel system. Okay, so with your Excel system, you can produce grades Then the output becomes will be received by the student record system. So if you have a grading system, what data will be coming from the student? So it will be their submitted work. So it can be a quiz, assignment, etc. So if we submit their work, we grade their work, and we return the graded work to the students. So our input, the submitted work, and our output, or what will be received by the student, will be the graded work. So for the teacher will be providing the grading parameter. Let's say, what ano ba yung grading parameter? Maybe, for example, how many quizzes will there be in 1 year? How many exams? What are the uh, maximum points per quiz, etc. These are the grading parameters. So once we record the graded work of students, what output can a teacher get from the grading system? It's a grade report. So the grade report can be received by the instructor. So after grading the work. So that's how we read a data flow diagram. Again, that's a context data flow diagram. All we have to do is entity, and then what will be the input, what will be the output, or what data will be coming from the entity, and what data or information will be received by the entity. That is all we have to place in a context data flow diagram. So let's proceed with the next one. Where are we now? Uh, Diagram 0. The diagram 0 displays more detail than the context diagram. So it can show entities, more or the major processes of the system, data flows, and also data store. So it is called exploded, partition, or decomposed version of process 0. So as I've said a while ago, the diagram 0 we have shown last time is actually the same or referring to the same system as our context diagram. Okay, so diagram 0 is actually the child of the parent context diagram. So they're referring to the same system. The diagram 0 is just an exploded version of the context diagram. Let's now read our diagram 0 we have last time. So a while back, this is our context diagram. Again, this data coming from the entities, and this will be the data received by the entities. Now, if we explode or we try to have a more detailed version of this process, so we can explode that into the diagram 0. That's why it's called diagram 0. Okay. So in the diagram 0, we should have the same number of entities compared with the context diagram. We call that balancing, which is after discussed on the next slide. And also the number of arrows from or to the entity should still be the same. So if you notice here, we have one arrow coming from the record system and one another arrow towards the student record system. So the same is true with this. So one arrow coming out and one arrow going to that direction. So this is now the explosion of that diagram. So let's take a look at this. So the student records will get the list of students, and then we have to establish the grade book. So as if we're typing or copying and pasting the names coming from this. So that's the process. So once we establish the grade book, we save that to our Excel file. So we have the names of the student, and at the same time, the columns of our class record. So we should know the grading parameters from the teacher, so that we can have the columns. So we have the names ready from the student record system, and we also should know the columns, how many exams, how many quizzes, what are the points of the quizzes, and all of these will be stored in our Excel file or grade book. So I'm assuming that the grade book here is an Excel system. Okay. Then what's next? The student will submit his work, and what are you going to do with the work? You have to grade the student work. If you grade the student work, what will be your output? You have the graded work that will be given back to the student, and we have to record the grade. So if you record the grade will be stored in the grade book. Okay. So basically, we produce the list of students, we accept student work, we grade their work, store. Always update the so we update the class record by storing the grades of the student. So at the end, maybe of the class or maybe at the end of a grading period, what can we do? We can read whatever is stored here. So we have the class detail, and we can use whatever is recorded here to produce grade report. And the grade report can be given to the instructor. Okay. Then also the grades or the data stored here will actually refer to the names and the grades can be read by this process to assign the final grade. So the grade will be computed automatically by the system, and the output will be stored back to the system, and other data will be given to the student record system. So that's how we read a data flow diagram. So what we have to do is to interpret what are the inputs and outputs. So that's an example of a diagram zero. Again, diagram zero because we exploded this diagram. Notice it is numbered zero. So here, these are now numbered 1, 2, 3, and 4. It is not necessarily that this will be the sequence. Okay, so let's take a look at the next slides. So we're almost through, I believe. Lower level diagrams. So we have diagram zero. We can go to a even lower level. So when do we have to go to another level? Actually, it depends on, so yan tinatawag leveling, we can have lower level diagrams. So it depends on, let's say for example, if you think you can, it is needed for you to provide more details to the diagram, then you can go to a lower level diagram. Now, if we go to a lower level diagram, or even at diagram zero, we should observe balancing. What do you mean by balancing? I have shown you a while ago that, for example, for an entity, there's one input, one output, one arrow. For the lower level diagram, it should still be the same. Okay, there should still be one input, one output. If not, then it is not no longer balanced. The data store might appear on higher level diagrams. So I don't think. So strategies, main objective is to ensure that your model is accurate and easy to understand. The diagram should have no more than 9 process symbols. So what if we have more process? Then we have to group in our diagram zero, for example, we have to group some of the process and then later on draw a lower level diagram. So that's it. That ends our representation. Thank you very much for viewing this presentation.